Hi everyone, today in Integrated Math 1, we're going to be going over Chapter 1, Lesson 7. So make sure you go ahead and write down the objectives as well in your notes. Alright, a function is a relation in which each element of the domain is paired with exactly one element of the range. This is what we were talking about on our last video. Notice it's only connected to one each time. However, if it was connected to another one, then it would not be a function. And remember, the domain and range can be shown as a graph as well. So, one thing we have to know is to be a function, it has to be able to pass the vertical line test. So think about this: if you have a pencil or ruler and you're rolling it across, rolling or sliding, depending on what you have, across the x-axis, which is this line down here. And if it only crosses at each point one time, because in order to pass the vertical line test, it can only pass once, then it is a function. However, let's say it crossed here at the blue dot and another time here, then that cannot pass a vertical line test. Alright, so let's go over example 12. We want to determine whether 2x minus y is equal to 1 represents a function. So first of all, we want to label this x and y. And the reason why we're doing this is to find out what points that we get so that we can graph it. So I always like starting off with 0 because 0 is one of the easiest ones you can start with. So 0 for x. So I'm going to do my work on this side. 2 times 0, remember I'm just plugging it in, minus y is equal to 1. 2 times 0 is 0, so I'm left with y is equal to 1. Remember there's an invisible 1 here. We want to divide that. Opposite of multiplication is division. So y is equal to 1 divided by negative 1. A positive divided by a negative gives you a negative, so negative 1. So one of our ordered pairs is 0, negative 1. And then let's go ahead and try a negative. So I'm going to say negative 2 for x. And it's really whatever you want. I try to have some positives, some negatives, and always a 0. Because you want to see what the whole graph is going to be looking like. You want to get the best idea you can. So 2 times negative 2 minus y is equal to 1. 2 times negative 2 is negative 4. Minus y is equal to 1. Add 4 to both sides. Negative y is equal to 5. There's a 1 here, doing the same thing that we did before. So y is equal to negative 5. So negative 2 and negative 5. And let's try another one. Let's try just 2. 2 times 2 minus y is equal to 1. So that's 4 minus y is equal to 1. Minus 4 minus 4. Negative y is equal to negative 3. There's a negative 1 here we can divide. Y is equal to 3. Alright, and I'm just going to go ahead and put another 2 that I've already solved out. And it would be 3 and 5 and negative 1 and negative 3. So now I have some points. And I'm going to go ahead and rewrite them here. I already have the points plotted here and I've connected to make the line. But we still haven't found out if it is a function. So remember, we're going to have like a pen or ruler or pencil, whatever you want, roll or slide across the x-axis. And see to make sure that it only crosses one time at each single point. In this case, anywhere where I have let's say the pencil, it's only going to cross once. Because of that, it is a function. Alright, and I just want to reiterate that there are many different ways to represent a function, such as a table, mapping, equations, and then to a graph. They all can lead up to a graph, or go the other way as well. They're all ways to represent a function. And that's it.